All right, okay. So, let's get started. Okay, let's go down. That's Ferris wheel, which I just recorded. If you're on the live stream, I just recorded Ferris wheel and it's uploading at the moment, but let's go over grid paths. So, let's do this. Okay, I hope you can see it. Can't? It's problematic. Okay. Um, that's probably because it's still uploading. Okay, so if you can't see the stream, oh, you can kind of. Okay. YouTube is throwing errors at me saying they're not receiving enough video to maintain smooth streaming. So if you can see smooth streaming, please say something in the chat. Okay, let's do this as soon as I see someone join. But otherwise, I'm still doing grid path. Okay, so let's create a new Disco template and call it main. Okay, oh, I guess we should go over the problem. So, the problem is there are 88,418 paths on a 7x7 grid from the, okay, hold up. Back, I'm getting Discord notice. Okay, let's get right back into it. Okay, so we have corresponds to a 48 character description consisting of characters up, down, left, and right. For example, this path corresponds to that description. So we are given a description of a path, and we are trying to calculate the number of paths that match the description. Okay, so we only get a 48 character. So first of all, let's get rid of this. And then let's first try and figure out if we can actually accurately get the 88,000 in a short amount of time. So let's see. Let's call a function solve 0, 0 to start the problem, and then let's just output a variable called w, which will be the number of ways. And then that can be our. So let's just do this. So we have long way equals 0. Oh, hey, someone joined. And then we need to create a void function called solve, and then it'll have a row and it'll have a column. So then, oh, I guess I should flip to YouTube. This screen so you can actually see me code. But, so let's see. We have a number of ways we can do it. So right now we're just trying to hit that 88418 number and accurately count the number of paths on a grid from the top left to the bottom left square. So let's do that. Basically, I'm thinking of just running DFS on every square that we hit, just to make it, I don't know, go fast. So I guess we also need a things that we visited and what we haven't visited. So let's just do bool visited, and then let's make it a 7x7. And then, so right away, if the RC is true, then we can just break. It's not even doing it. State, oh. Okay. If we haven't visited it, we need to basically just run DFS. So we need to see if we can go up, down, left, or right. So if we can go up. So if we can go up, so r is not equal to 0, and so let's just do if r is greater than 0, and we haven't visited r minus 1, c, then we want to solve v or r minus 1 c. And you know what a terminating condition would be? A good terminating condition would be to see how long our path is. So let's just do our, what if we just make a thing of steps? So we can just do steps equals, and then at the beginning we have no steps. Or we can start off with 1. No, no, no. Okay, so we need 48 steps. So let's just do if steps equals 48. Oh, no, we just need to end off in that. So we can just do plus, and then if we get, we just solve that, and then steps minus. And then we need to just basically check each condition in all 4 directions. So if r is less than n minus 1, or 7 minus 1, so 6. If r is less than 6, so we can get up to 6, then r plus 1c and r plus 1c. And then after that, then if c is greater than or equal to 0, then we just go to r minus 1. And then if c is less than 6, then we just go to c plus 1. Okay. Okay, so now that we've gotten that, okay, so now we should see, oh yeah, okay. If we hit the bottom, RC, R equals 6 and C 0, then return at the bottom. If steps 48, then we want to W plus. And then let's just do some simple optimizations. If r equals 6 and steps does not equal 48, then return anyway, because we want to like get out of it. If we hit the bottom left corner without steps hitting 48, there's no way we're going to be able to go back to that area because we can't cross over it, so we just return straight out anyway. Let's see if we can actually run this in time and if it gives us an accurate. So we get 0. Why do we get 0? Okay, so solve. Let's see. So if r equals 6 and c equals 0, oh, we need to set v of r equal v, and then when we backtrack, we okay. So let's test this. Still get 0. So what did um so We're not even like getting 7, 7. So 0, 0. Hmm. See. Is that the problem? That was. Um. That's. Oh. Oh, we're not hitting any of these. They should all be false. Now, we should have it run for a while, which it is. So I'm just gonna let that run while we come up with other things because we do have ending. So I'm not afraid of it or not afraid of it not ending, but let's try and figure out some optimizations while that runs. So we do have okay, so we already have the if so let's do if it hits a wall and there are areas like okay, if the if there's a wall in front of it and can't go behind and it can only go like say two directions, up, down, or left, right, then you can't solve it. So let's stop it there. So if the let's just add on to t equals the option or if yeah, then okay, or if v are -1, v for r has to be greater 0 and c has to be okay. Let's do top wall first. So if it hits the top wall and there's nothing for it to go up, so that means r. Hey, we got it. So if r is going to go up and there's nothing it can move left. So if r equals 0 and c is greater than 0 and c less than 6, so that means c equals 1, 2, 5, which means we can go in either direction for c. And the r c plus 1 is true is false, and v c minus 1 is true. And let's just do for good measure r minus 1 c is visited, which it should be, then return. So let's see if that speeds it up any. And also I'm going to up one note because I do have a clock script you guys can see here that I am going to put in top and bottom just to see how long it takes the entire solution. So it's gonna top and then it's at the to just see how long the um, the solution takes. So now with the updated with the updates, oh, you guys can't see. Okay, with the updated just hitting the top, and then we just cancel out. Let's see how long it takes. And then there's also if it hits the bottom and it can't go in. So it would be same actually, just R equals. Okay, so if R equals 5, and C is greater than 0, 6 is no R minus, and then the one above it. Stop. Run it. Okay, and then now the walls. So if C equals 5 and R is greater than 0 and R is less than 6 and C or R plus 1 C and oh, we got a wrong answer. Okay, so something's wrong here, and it took 28 seconds. So let's just do this bit. We're going to do just this bit to see if the wrong answer is in there. And now, for about 45 seconds, we have to wait. After that, I am planning on putting in the optimization where it hits the wall and it can turn left or right. Or if it hits its own path and it can turn left or right, then there can't be a solution because it would have to can't cross over itself. So if it hits a wall and it can go left or right, it can either choose one, and on one of the sides, it created a loop as it hit itself because it can go left or right. If it filled in that loop, that's great, but it didn't because there's a spot open for us to turn left or right. And then that should put us through. If anyone wants to throw in another problem while we're waiting, that'd be fine. Here, let's just implement the hitting the what's it called? Hitting the board. Okay, so this one does work, and it took us 70 seconds. Okay, or at least I think it does. We're gonna just run it just to make sure it is in fact speeding it up a little bit. I'm just gonna run it on its own, and if it takes more than 70 seconds, it's 2052 in the stream right now. If we're past 2110, and we'll say stop. Okay, so now we figure out what was wrong with spit. So if C equals 0 and R is greater and R is less than 6, R plus 1, same column. So we're hitting column 0 and we're hitting it 1 through 5. So it's 2. And then it's true. Oh no. And then it's way past 2210. I'm just gonna let that run for a little bit and then we will test the next one out. Okay, so now actually let's just okay, so obviously it works. So now let's put in this one and hopefully it'll cut it down to around a couple seconds. But I'm assuming it'll take. So let's say we have C equals 6. and R 0 and 6 and 1 C R minus 1. Awesome. It only took us 39 seconds. C and V C minus 1. So what we need to do is I'm actually going to cut down on the number of comparisons here by noticing that we only need to look at this bit and this ending bit. And that's the only thing that's differentiating between the two. So we're actually going to double parenthesis this. This is going to be so unreadable code, by the way. So sorry. And then we just take this. And then see. Okay. So now we just need to copy this for the what we're going to do, I'm just going to find and replace. Same code. Okay. So it's going to find and replace that. C D R plus 1 minus 1 0 minus 1 and it's physics. Okay. Let's now make sure this works. Just a ton of logic. And it did work. And wow, we cut it down to 1.7 seconds just with that. With all that comparisons between 0 and R and C and all that, and we got it down to 1.7 seconds. So now we just have one big push to do, and that is the sides. If it hits a border, we stop. So let's do that. If it hits a border, then what's going to happen is B of, okay, let's just say we're in a situation where R does not equal 0. All those situations have probably been compared for. But let's just say B of R plus 1, the row below us, full, and V of RC minus 1. I'm just doing this first because then we can define domain and stuff. And V of RC plus 1. We're just trying to knock the amount of time it takes to get 88418 down to under a second. And then after that, we just get rid of the ones where we force sections, and then so all we need to do is just get this under a second, and then we're good. V C R plus 1. Okay, so okay, so the two sides around V are the two sides around R and C should be empty. The one in front should be full, and the one behind should be VR. So this just means okay, then return. So we just need R to be greater than 0 and R and C greater than 0 and C and now let's see how long this takes. Should only take a couple seconds. And okay, it knocked off 0.7 seconds. Wow, okay. Now we're doing this for columns too. Um, okay. Or no, we're gonna do it for our. Oh yeah, okay. So we're just gonna do it. We don't need to worry about that. That's gonna stay the same. Our -1 and -1, and then it's -1, and then oh, we probably could have done an XOR there and clean that up a bit. Let's just see if we knock this under a second, and we do. All right. Okay, so we've knocked down calculating all the ways we can have paths throughout a 7x7 down to under a second through all this lines of logic. And then now we've got to force moves. So let's work on that. So we've knocked it down to 0.7 seconds, which isn't that great, but it's good enough since we don't have to like keep going with it. We're just stopping at 7. So since the number of paths underneath or in the 7x7 is going to be less than 88418, we could just test all 88418 to see if they match the pattern. But we're going to do it a smarter way, and that smarter way is we're going to reserve some steps. So if some steps are reserved, so int reserved, just going to make this 49, although there should only be 40. We're just going to make it 40. Okay? And then what we're going to do is we're going to string str, and then we're going to take in str. And then for all the letters in str, and all we have to do is just adjust it. So if let's just no, if tr I question mark, then I equals -1. Otherwise, it equals I'm just gonna say up is 1. Uh, 0, I guess. Just need to. Okay, and then 8 down, and then left. So then 1, 2. Okay, so now we have parsed the entire thing, and now let's see. So steps starts out at 0. So on the first step, it's at 0, which makes it perfect because then we can just see if reserved steps does not equal -1, then at the end we're just going to return early. Okay. So if it does not equal -1, then if, you know what, we're just going to copy all down left. We're just going to copy all this and just add some steps. So if reserved steps equals 1 and reserved, okay, so this is the if reserved steps, just gonna make a switch. Steps, just, and then case 0, and then 1, and this is actually, so up is 0, right? Then right is 1. Oh, so we're just going counterclockwise. So down would be 2, case 3, 1 for right. Oh no, this is, and then case 1, and then break. And then I think that should be, and then I guess set it. Okay, so with doing all this, let's see if we get 201 if string. Yes, we do. All right, okay, so that's a problem. We are getting to 2.4 milliseconds, or 2.4 seconds. So we might need to optimize this a tad more. Let's just upload this and see if it works, because I have a feeling that it will indeed. At 2 seconds on my computer, usually it works faster on server computers, but we never know. It may be a little bit too slow, in which case we would need to try again. But it got accepted with under 0.5 seconds, so that'll be it for this live stream. If you would like to see more live streams like this where I live stream me doing the problem. This wasn't my first time doing the problem, but this is a pretty long problem and I didn't want to upload the video later, so I did want to live stream it. So if you want to see any more problems like this, let me know. Comment down below, like the video, subscribe. You know what to do. Yeah, if you have any faster solutions than what I did was pretty logic heavy, from like the 5 or 6 lines of just pure logic that we had to write. But if you know of any faster solutions, any cleaner solutions, comment them down below. Send me an email. My email's on the about page. Send me a Discord. Anything you want, and I will make a video faster. So thanks for watching, everyone. Thanks for tuning in. For those of you that did, see y'all later. Goodbye. Thanks for watching. Goodbye.